Alright, what's up guys? In this video I'm going to be talking about rational inequalities, and this is the fourth lesson in the 7th unit of College Health. And before we talk about rational inequalities, first I want to just talk about, making a number line and determining whether a function is positive or negative over certain intervals. And so I'm going to start by looking at f of x equals x squared minus 5x plus 6. And on second thought, I actually decided I wanted to change that to x squared minus 6x plus 8, just to make it a little easier to look at. Okay, so the first thing I'm going to do is I'm going to factor this thing. So I'm going to say that this is the same as x minus 4 multiplied by x minus 2. Okay, and in the last unit, we solved quadratic inequalities, which oftentimes ended up being equivalent to finding where a quadratic function was positive or negative. And what we did in my sections was we drew a picture of the graph. We drew the parabola through the zeros and determined whether it was above or below the x-axis. And now on rational inequalities, that's not going to be possible because we don't know what the graphs of these things look like. They can be, pretty weird looking. But I'm going to show you the technique we're going to use here. We know that the zeros of this thing are at x equals 2 and x equals 4. So we know that the graph of this thing, and we know it's a parabola, and it's going through there. And so it's going to be positive for x values less than 2. It's going to be negative for x values between 2 and 4. And it's going to be positive again after x equals 4. But we're not going to be looking at it this way, like I said. Okay, so we're going to get rid of all this. And we're going to test values. Okay. So what you got to do is we'll start in the middle. Okay, so you just choose any number between 2 and 4, and of course you're going to want to choose a whole number. So you'll choose x equals 3. And then what you'll do is you will determine whether or not the function is positive or negative over the interval 2 to 4 by testing the value of the function at x equals 3. Okay, so at x equals 3, f of x is equal to 3 minus 4, which is negative 1, times 3 minus 2, which is positive 1. Okay, so negative 1 times 1 is negative 1, so it's negative. And the reason that we can do this is because these polynomials are continuous functions on their domains, and the only place that it's going to switch from positive to negative or from negative to positive is going to be at one of the zeros of the function. So I'm going to do the same thing outside of 4. So you can choose 5, or you can choose a number much larger than 4. And I tend to like to choose one much bigger than 4 because you're less likely to make some sort of like arithmetic error or something. So I'm going to just choose like x equals 10. Okay, so you take 10 minus 4, and that's 6, or some sort of positive number. And 10 minus 2 is 8. Okay, so we got positive times positive, and that's going to be positive. And then you choose something less than 2, and you always want to choose 0 if at all possible, right? So I'm going to choose 0 over here, and I'm going to say x equals 0. And I'm going to say 0 minus 4 is negative 4, and 0 minus 2 is negative 2. We multiply those, and we're going to get positive 8. And so for the interval where x is less than 2, f of x is going to be positive. Okay, for our first example, we've got a fraction, and we're interested in where it's positive, or at least greater than or equal to 0. And so we've got x plus 3 over x minus 4 is greater than or equal to 0. And the first thing we're going to do is we're going to draw ourselves a number line. Okay. Now, if the numerator and or the denominator were not factored, we would need to factor those first. But since they are already, as factored as they're going to get, we're good to go. So we think about the zeros of the numerator and the denominator. Later, we'll talk about how the zeros of the denominator will cause a vertical asymptote, and I am kind of presuming that you saw that in Algebra 2. But the fact is that the sign of the fraction, positive or negative, is only going to change at either a 0 of the numerator or a 0 of the denominator, if it's going to change at all. And so what I'm going to do is I'm going to, put down the zeros of the numerator and the denominator. So that would be x equals negative 3 would be where the numerator equals 0, and x equals positive 4 is where the denominator equals 0. Then I'm going to test values, just like I did with that quadratic function earlier. Okay, so I'm going to just choose, if I can choose 0, I'm going to. All right, so I'm going to choose x equals 0. Then we've got 0 plus 3 is 3 over negative 4, and that's negative. Okay, so I'm going to put a negative there. So for all x between negative 3 and 4, that fraction is negative, and that's not what we're interested in. Okay. At x equals, let's say, 10. We've got 10 plus 3 is 13 over 6, and that's going to be positive. And we see that for any x bigger than 4, we're going to have positive over positive, right? Because a number larger than 4, and we subtract 4 from it, it's still going to be positive. And then over here, I'll choose something like, how about like negative 100? You know, something really, really negative. So we get the picture. Okay, well, negative 100 plus 3 is going to be negative 97. Negative 100 minus 4 is negative 1 over 104. And if we have negative over negative, that's going to be positive. So for these exterior intervals, we've got positive and positive. Okay, so we're almost done, right? But we're interested in where this thing is greater than or maybe potentially equal to 0. And so for that, I'm going to need to check these actual points at negative 3 and 4. Okay, so we're going to just kind of x equals negative 3. We have 0 over negative 7. That's okay. That's equal to 0. Okay, so that's good. Okay, just include that as well. And then I'll try x equals 4. And then I get, okay, that's going to be 7 over 0. That's not a real number. And so a real number can't be greater than or equal to 0. That's not going to be the case. Okay, so this is, no. Okay, so we'll just kind of put an open circle there to indicate that that's not part of our solution region. So we're interested in where this thing is greater than or potentially equal to 0. And so that'll be where x is less than or equal to negative 3, or where x is greater than positive 4. And we'll be happy. Next, we've got one where we've got a fraction and it's greater than 2. And so the first thing we're going to need to do here is set this thing equal to 0, or greater than or less than 0. Okay, because our strategy is to kind of analyze whether the thing is positive or negative, making a number line. And so positive or negative, doesn't really tell us whether a thing is greater than 2 or not. Okay, so what I'm going to do is I'm going to do a little bit of algebra to get this thing as a fraction greater than or less than 0. All right. So I've got x plus 3 over x minus 1. Minus 2 needs to be greater than 0. Okay, but this, we need one fraction greater than 0. So what I'm going to do is I'm going to need to change this 2 and get a common denominator, basically. So I multiply by a clever form of 1, okay, to get a common denominator. And I'm going to have x plus 3 minus 2x minus 2. Okay, so that's going to be x plus 3 minus 2x plus 2 more. Okay, so this is going to end up being negative x plus 5, or 5 minus x. And we still have that same denominator of x minus 1. That's why we get the common denominator, so we can add these fractions and turn them into one fraction that we can analyze. Okay, so the first order of business is we're going to make a number line. And we label the zeros of the numerator, that's going to be x equals 5. And the zeros of the denominator, that's x equals 1. And we're going to test some values. Okay, so I'm going to test x equals 0. Right? That's going to be an easy one. So x equals 0. We've got 5 minus 0 is 5, which is a positive number, divided by 0 minus 1, which is a negative number. Positive divided by negative is negative. Okay, so I'll say it's negative out here. Between 1 and 5, I'm going to choose 2. Why not? So x equals 2. Okay, when x equals 2, I've got 5 minus 2 is 3, which is a positive number, divided by 2 minus 1 is 1, which is a positive number. Positive divided by positive is going to be positive. Okay, so I'll put that there. And then something bigger than 5, how about 100? Okay, 5 minus 100 is certainly a negative number, and 100 minus 1 is going to be a positive number, and negative divided by positive is going to be negative. Okay, so I determine that it's negative out there. And I'm interested in where this thing is just greater than 0, so I don't have to worry about it being equal to 0. I don't have to test 1, I don't have to test 5. I'm just going to say it's going to be this interval here. And so my solution region is going to be the set of x values between 1 and 5. And if you feel like you're needing more practice with these, kind of basic ones, here's 2 for you to work on. Okay. Now, if you're feeling like you're good to go, you're ready to move on to some more difficult examples that you're seeing later on in your notes packet, you are free to go ahead and do that. What I'm going to do is I'm going to pause the video and I'm just going to flash the answers up here in a couple of seconds, and then you can see it. Are you getting it right or are you not getting it right? And if you're not getting it right, you might want to come see me in the morning and talk about it a little bit. All right, there you go. The next example I've got for you is, kind of stepping it up a little bit because it's got multiple factors in the numerator. Okay, and so if we've got multiple factors in the numerator or the denominator, it really doesn't matter. It's just going to be more spots on the number line that we're going to have to test. And that's not a big deal. So I'm going to make myself a little number line. And I'm going to say that the zeros of the numerator are going to be -3 and +1/2. So there's -3. Here's +1/2. And the 0 of the denominator is going to be x equals 5. Okay, so I've just got more intervals to test. Okay, so I'm going to just start with, let's just say x equals 0. Okay, and that's always a good place to start. So x equals 0. I've got 0 minus 1 is a negative number. 0 plus 3 is a positive number over x minus 0 minus 5 is going to be a negative number. Okay, so I've got negative over negative, positive. Okay, this is going to be a positive answer. And then a number between 0.5 and 5, I'm going to choose x equals 1. Okay, so x equals 1. And when x equals 1, I've got 2 minus 1 is 1. 1 plus 3 is 4. Over 1 minus 5 is -4. Okay, and so I'm going to just, sometimes you can just write positive, negative if you like, and you can put the actual numbers if that makes you feel better. It really doesn't matter. Okay, so I've got 4 over -4 is -1, which is a negative number. Okay, so it's negative through here. And then I'm going to just choose another value, maybe bigger than 5, like say 10. Okay, when x is 10, I've got 20 minus 1 is 19, which is a positive number. 10 plus 3 is positive. 10 minus 5, also positive. Okay, so all positive, that's going to be positive. And then a number less than -3, maybe -10. Okay, when x is -10, I'm going to say that it's going to be -21 times -7 over -15. Okay, and I've got 3 negatives, that's going to make a negative. All right. And so if I'm interested in where this thing is positive, okay, that's this interval here, I'm saying plus sign, and then this one out here. Okay, so the solution region is going to be -3 up to 1/2 union 5 to infinity. Okay, you can write it as an interval. If you'd rather write it as an inequality, you could say -3 is less than x is less than 1/2, or maybe x is greater than 5. Okay, both of these mean the same. So however you like it. So at this point you might be thinking, well, why don't I just test one of the intervals and then just alternate positive, negative, positive, negative, positive, negative? And I'll show you why that's really not a good idea. Okay, so here we've got one where I've got x squared minus 8x plus 16 over x squared minus 10x is less than or equal to 0. And what I'm going to do is I'm going to start by factoring this thing, because that's the way that we find the zeros of a quadratic or a polynomial, is by factoring, usually. And these are both factorable. And that'll be the fastest way for us to put down the little spots on our number line that are going to dictate the intervals we test. So I'm going to factor this thing. X squared minus 8x plus 16 is x minus 4 times x minus 4. So it'll be x minus 4 squared. And then x squared minus 10x will be x times x minus 10. Is less than or equal to 0. Okay, that's what we're interested in. Now, I'm going to kind of, just like always, I'm going to make a little number line. And so the 0 of the numerator is x equals 4. And the zeros of the denominator are x equals 0 and x equals 10. So we're just going to kind of test some values and see what's going on here. And I'm going to tell you that it's not just going to alternate positive, negative, positive, negative, positive, negative. Okay, so let's try x equals 1. So x equals 1. I'm going to have, well, no matter what I put into the numerator, it's going to be positive because I'm squaring. Okay, it could be 0 if x equals 4. And so, well, that would be a solution. So while I'm talking about it, I'll just indicate that that's a solution as well. Okay, x equals 0 and x equals 10 will not be solutions because they're going to cause us to divide by 0, and dividing by 0 gives you something that's not a real number. And so a real number can't be less than or equal to 0. Less than or equals is a relationship that only two real numbers can have. Okay, so if you have x equals 1, we're going to have a positive number in the numerator, and we're going to have positive, x is positive, but x minus 10 is negative. Okay, so that's negative. Okay, that's going to be an info we're interested in. Okay, what about x equals negative 1? And let's try this one also. Okay, when x is negative 1, I'm going to have positive because I'm going to have negative 5, but I square it, and that becomes positive 25. Divided by negative 1 times negative 1 minus 10 is going to be a negative number, and I've got two negatives, and that's going to make it positive. Okay, so I'm positive over here. You might be thinking, I don't believe you, it's going to alternate. And so we're going to try like x equals 5. And so x equals 5. And when we have x equals 5, we'll have a positive numerator. And the denominator will have 5. Well, that's positive, right? It's right, positive. Times 5 minus 10 is a negative number. Okay, so that's negative. And so we see that really that squared object is what's causing it to not change sign. And if you really remember from Algebra 2, or maybe pre-calculus if you took that course, when we have a squared factor, especially in a polynomial, that's going to cause the graph to bounce at 0. And it's when it just bounces on the x-axis, it's not really indicating a sign change. So that's kind of what we're seeing here, in a sense. And then I'm going to choose something bigger than 10, like 100. So x equals 100. I'll have positive over positive times positive, and then it'll all be positive. Okay, so my solution region in this case is going to be all of these, including the 4, and all the way up to 10. So really what it is just going to be 0 is less than x is less than 10, or x is between 0 and 10. So it's an interval if you like. And that's kind of why you really want to be careful about just plugging in one value and then alternating. Okay? You don't want to do that. All right, here we've got another one. And this is one where we're going to need to factor at the beginning. But unfortunately, the leading coefficient is not 1. And I feel like this is the type of thing that I need to remind y'all about just about every class period. Okay? Because we are not super strong on factoring these. But if you stick with it and you just keep practicing along with me, by the end of the year, I feel like you've got to be able to pick it up. Okay, so we're going to start by factoring 5x squared plus 18x minus 8. And I might just do this kind of off to the side in gray, and it's going to go away after a while. But for now, okay, I'm looking for two numbers that multiply to negative 40 and add to positive 18. Okay, so I'm thinking positive 20 and negative 2. Okay, so plus 20 and minus 2. And then what I'm going to do is I'm going to take this 5x squared, 18x, and negative 8. I'm going to take this 18x, and I'm going to split it up into the 20 and the negative 2 that comprise it. So 5x squared plus 20x minus 2x minus 8. And then I'm going to group and factor. Okay, so the common factor between 5x squared and 20x is going to be 5x. So that's 5x times x plus 4. And then negative 2x and negative 8 have a negative 2 in common. So I'm going to factor out the negative 2, and I'll be left with an x plus 4. And I factor out the x plus 4, and I'm left with 5x minus 2. Okay. So I'm going to rewrite this inequality over here on the left as x plus 4 times 5x minus 2 divided by x minus 5. And that we're interested in where this is negative. So I'll start by, making my number line just like always. And this is the type of thing where when you're doing the practice problems or the homework or you're doing the quiz next time, pretty much every problem needs to start with a number line. That's the beginning of getting credit, in my opinion. So, your grader is going to be looking at it and saying, well, did they have a number line? If not, then they're going to be getting credit. Okay, so we really always have to start with that. Once we've got it down to a factored fraction, greater than, less than, greater than or equal to, less than or equal to 0. Okay, so the zeros in the numerator are going to be x equals -4. And wherever 5x minus 2 equals 0, so, maybe you see what it's going to be, or maybe you need to do a little bit of algebra. So x equals 2 divided by 5, which is like 0.4. So I'll just, kind of label that 0.4. And then the 0 of the denominator is going to be x equals 5. Okay, so I've got my number line set up. I'm ready to test points. I'm ready to get a solution. So I'm going to test something like -10. All right, when I have -10, I'm going to have, -10 plus 4 is -6. -50 minus 2 is -52. Negative divided by -10 minus 5 more is going to be another negative. Okay, 3 negatives is making a negative. Okay, then something between -4 and 0.4, that's going to be 0. Okay, so I'm just going to try. I'm going to plug in 0. I'm going to get 4 times -2 is -8 over -5 is going to be positive. Something between 0.4 and 5, I'll choose like 2. And then I will say what happens when x is 2. I've got 2 and 4 is 6, which is positive. I've got 10 minus 2 is 8, which is positive, divided by 2 minus 5 is negative. So I've got a positive number divided by a negative number, and that's going to be negative. And then for x is bigger than 5, I'll choose like 10. You can choose anything bigger than 5. You can choose 6. You can choose 5.5. You can choose 5.1. Okay, I'll choose x equals 10. So I'll have 10 plus 4 is 14, positive. 50 minus 2 is 48. 10 minus 5 is 5. All positive. That's going to be positive 3. All right, so I've got my interval. I'm interested in where this thing is less than 0. Okay, so at all of these points, this fraction is either going to be 0 or it's going to be undefined at these places that I've labeled in black, the zeros of the numerator and the denominator. And, well, 0 and undefined are, neither of those are less than 0, so I'm just going to, fill in all those as open. Okay, I'm interested in where this thing is negative, so I'm kind of shading in, and I'll get my answer. So x is less than -4, or x is between 0.4 and 5. Okay, next I've got one that, looks innocuous enough, but it's got a lot of moving parts, and so I think it's definitely one that we should do. And this is one from your notes packet. The past one or two were not included, but I definitely wanted to include one with, a repeated factor, and more with greater than or equal or less than or equal to 0, because those are kind of the things that can be tricky in this. So I'm going to start by setting this thing to 0. So I've got 3x minus 1 over x plus 4 minus 2 is greater than or equal to 0. And so I'm going to need to get a common denominator to actually combine these fractions, get one fraction greater than or equal to 0. Okay, so I am going to get that common denominator. I want to have x plus 4, so I need to multiply by x plus 4 over x plus 4, right? We have this 2, and we don't want to change it, right, because that would change the nature of the inequality. So we multiply it by 1, but our form of 1 that serves us well. Okay, so this is 3x minus 1 minus 2x plus 8, so it's minus 2x and minus 8 over x plus 4. We're interested in where that is greater than or equal to 0. Okay, so I put these all together. I've got 3x minus 2x is 1x, and -1 minus 8 is -9. So I'll just rewrite that as x minus 9. And I think I'm just going to write that fraction. Looks a little out of proportion. So I've got this, and now all of a sudden, this is not such a bad one. This is one that we feel like we can do. And if you just looked at this, this is one of the basic ones that we did at the very beginning of this. So let's just go ahead and make our little number line. We've got -4 and +9. Okay, so the values I'm going to choose will be, say, 0, 100, and maybe -100, just for ease. Okay, and so I'll start with -100. Okay, I'll plug it in. -100 minus 9 is -109. Divide by -100 plus 4 is -96. I've got negative divided by negative. That's becoming positive. X equals 0. Okay, I'll have -9 over 4. Okay, we like 0. That one's really easy. Okay, so that one's negative. And then x equals 100 is going to be, well, 91 divided by 104 is indeed a positive number. Okay. So I've kind of set it all out. But the one thing that I have to do at this point is when you have greater than or equal to 0, you have to test the edge points as well. Okay, so I'm going to talk about x equals -4. I'll have, well, that'll be -13 over 0. That is not equal to 0. Okay, so we're not interested in that. Okay, and then +9 is going to be 0 over 13. And 0 over 13 is 0, so I will include that. Okay, so I'm interested in where this thing is greater than or equal to 0. Okay, I labeled where it was equal to 0, that's x equals 9, and where it's greater than 0 are kind of these intervals over here. And so my solution is going to be x is less than -4, or maybe x is greater than or equal to positive. All right, now these last couple of examples are going to be ones that are kind of, more on the fringe of what we're doing. They're going to be the more difficult problems that will appear on the quiz. Okay, so here we have fraction and fraction. Okay, that's not something that we've done. But the same principle applies. We need to start by setting it equal to 0. We got to get a common denominator. Okay, so I'm going to say 4 over x plus 7. I'm just going to prepare for the fact that I'm going to need to get a common denominator. Minus 3 over x plus 8 is going to be less than 0. Okay, but I need to get this common denominator. So x plus 7, x plus 8, x plus 8, x plus 7. And we're just going to have to kind of match that in the numerator. All right, so this is going to be 4x plus 32 minus 3x plus 21 divided by x plus 8 and x plus 7. All right, so I need to start combining like terms. I'm going to have 4x minus 3x is 1x. 32 minus 21 is 11. So I have x plus 11. And just like always, I'm going to make my number line. I'm going to put -11, -8, and -7. And so I'm just going to choose values like -20. And so I'll have negative, negative, negative. 3 negatives makes negative. Something between -11 and -8, let's say -10. If I plug in -10, well, the numerator will be positive because -10 plus 11 goes back positive. And then in the denominator, I will have 2 positives, so I'll have positive, or no, I'll have 2 negatives, which will make a positive. So I'll have positive divided by positive, which is positive. Okay. Between -8 and -7, okay, this one I wanted to make sure I had one like this. Okay, this is a little bit annoying, but you're going to have to choose something like -7.5. But -7.5 is a good example to really see how this works, right? Because we'll have x plus 11, which will certainly be positive, right, for any x between -8 and -7. And so -7.5 plus 8 is positive 0.5. Whereas -7.5 plus 7 is going to be negative. And so we see that that's really kind of getting at what we're doing here is that, numbers in between these are really kind of picking at the differences between our factors. Okay, so I've got negative here. Oh, whoops, slid over on me. All right. And then I'll just choose x equals 0 just for ease, and I'll have positive, positive, positive. Everything's positive. Okay, I'm happy. Okay. And then I'm interested in where this is less than 0, so none of these will be of interest to us, even if it's equal to 0. We don't care if it's equal to 0. We want where it's less than 0. Okay, so it's going to be this interval and that interval. Okay. So this is going to be x is less than negative 11, or maybe x is between negative 8 and negative 7. All right, now the last example I've got for you is probably, higher degree than we're going to be seeing in this class. Okay, I've got kind of a triple factor of x plus 5 and a quadruple factor of x in the denominator. Okay, but since this thing's already factored, I'm going to be, pretty much ready to go. I'm ready to write down a number line. Okay, so there it is. And the zeros in the numerator and the denominator are going to be negative 5, 0, and 1. Okay, so negative 5, 0, 1. And I'll just choose some x values here. I'll just do negative 1, 0.5, 10, and maybe negative 10. Then I'll start testing some values. So negative 10 is going to give me negative 5 to the third is, I think, negative 125. Either way, it's definitely going to be negative, because the negative number to a third power is going to be negative. And I'll have negative 10 minus 1 is negative 11. Divided by negative 10 to the fourth is going to be positive. So I've got positive divided by positive is positive. Let's plug in x equals negative 1. Okay, that's going to be 4 to the third is going to be positive. Negative 1 minus 1 is negative 2. That's a negative number. Divide by negative 1 to the fourth, which is positive. Okay, so if I switch signs, it's negative through here. And then between 0, I got x equals 0.5. Looks like I'm running out of room. And so I will plug in 0.5, and I'll have 5.5 to the third. I have no idea what that is. I don't need to know what it is. It's a positive number. Okay. 0.5 minus 1 is negative 0.5. That's a negative number. And 0.5 to the fourth is going to be a really small number, but it'll be positive. It's like a 16th. And so I'll have negative divided by positive is negative. Okay, and then I choose x equals positive 10. And that's going to be, well, everything's going to be positive. I'll have a positive number to the third power. I'll have another positive number in the numerator. I'll have a positive number in the denominator. Lots of positive. So positive, positive, positive. Everything is positive. Okay, but again, since I've got this greater than or equal to 0, I need to test the edge points. The actual zeros, the negative 5, the 0, the 1. Okay, so I'm going to test negative 5, test 0, and I'm going to test 1. Okay, at x equals negative 5, I'll have 0 over negative 5 to the fourth, it'd be 0. When x is 0, I'll be dividing by 0, so, that fraction doesn't have a real value, doesn't exist. And at x equals 1, I'll have, again, 0 divided by 1 is going to be 0. All right, so at negative 5, we have equal to 0. We like that. At x equals 0, the fraction doesn't exist, so that can't be equal to 0. And then at 1, it's going to be 0, so I like that too. And then if I'm interested in where this thing is positive, greater than or equal to 0, okay, that's going to be x is less than negative 5, so negative infinity up to negative 5. Except we are going to include negative 5, so that wants to be a squared bracket. Union 1 to infinity, and we want to include 1 as well, because at 1, the value of the fraction is equal to 0. Or you could write this as x is less than or equal to negative 5, or x is greater than or equal to 1, however you want it. All right, I think that's all I got for y'all. If you've got more questions on this, you should definitely come see me in the morning, or, ask a friend, somebody else that's in college algebra. You should work the rest of the problems on the example packet. We've got a pretty solid set of questions for homework that's available to you also, and there's also a key that's, I believe, linked to the homework. So there's lots of practice out there. This is kind of something that's new for us, this writing down a number line and testing values. So it's something you're going to need to practice. And I'm available to help you practice.